everyone, welcome back to Big 4 channel. In this project 2 series, you will be taking your second toddler step or your second program today. You'll be writing your second program today. Okay, so the second program will be sort of the same as the first program. There won't be much difference, but you have a lot to understand because I will teach you how to use this external light bulb in your circuit. I'll also teach you the principles on which this breadboard works. I will teach you how to take a schematic from the purge into a circuit on the breadboard. And then I'm going to teach you, to try to explain to you a little bit about microcontrollers and what is their operating principle. And then also on the light bulb, on this LED, I'm going to also give you a little bit of understanding on which principles it works. So I'm going to start with this LED. So the LED is made from a semiconductor material, normally silicon. Okay, so the way the semiconductor works is before that, a semiconductor is sort of an in-between between a conductor and an insulator, but it's a bit more than just that, in that semiconductors with the right current or with the right voltage released into a semiconductor, we can alter its state to become a conductor or an insulator, which means we can control the state of the semiconductor. Okay, so back on the main topic, this LED, the way it operates is light is produced from this LED by the movement of electrons, or can I say by jumping of electrons from what we call from one energy level to another. Okay. If you want to learn this a little bit deeper about this, you may find other videos okay, on how an LED actually works. But basically, it's just the jumping of electrons from a certain level to another. So as they move from one level to another, they produce light. So the light is what you use every day. Most of the lights that you use these days are LED. So why did we have to leave the old bulb and then abandon the old bulb and then choose to use the LED? Okay, this is why, my good friend. So the principles on how the old light bulb worked was the old light bulb used the principle of resistance, in that if we produce, or if we release a bit of amount of voltage into a resistance, it heats up and then produce light. But the problem is, fundamentally, heating the resistance is a heat producing process. It produces a lot of heat, and then maybe with enough heat we might produce light. So at the end of the day, you find out that in our people in houses in hot weathers, you see that on top of turning the LED, the light bulb on, the head to run the aircon, you see, so you are losing energy in form of 90% heat, 95% heat. Okay, you are also losing energy in trying to get rid of that 95% heat by turning on the aircon. We all know that heat is money. That is what it is, since we pay for this electricity. So on the economical aspect, using the old light bulb was not something that is economical. We had to abandon that to use these LEDs. Okay, so we are done with this LED. So after the LED, I'm going to explain to you what a microcontroller is. So a microcontroller is made from semiconductor material, just like the light bulb. Okay, so a microcontroller is sort of millions of switches. You can look at it as millions of switches that are housed in this shell. So these millions of switches with the right voltage and signal we can be able to play around, turning them on and turning them off. So that is basically what we'll be doing when we are programming. We are manipulating the switches in here, or the properties of this semiconductor material. So that is what basically a microcontroller is. So lastly, we have to talk about the breadboard. Okay, so the breadboard is just a way of, or it can also be called a prototyping board. It allows us to take our circuits from the pages or from the planning phase and then put it into practice and then test it as prototype on this board. That is why it's called a prototyping board. So as you can see, if you look closely at this prototyping board, we have positive here, the red ones. We have positive, negative, and then we have these O's, and then we have positive, negative. So I'm going to explain first what this thing is. Okay, so this line here that you see right there has two long wires. So the first long wire is labeled red here. This, I'm talking about the internal mechanism of this part. Okay, so we have a long wire which runs from this end to that end, which we have labeled positive. And then next to the positive, we have another wire which runs from this end to this end. So these two wires, they are not linked together. Okay, so they are not connected, these two wires, but they are just one wire that run from top to bottom for the positive, and then another wire which runs from top to bottom for the negative. Okay, so each and every hole that is near to the negative, to the positive mark, is connected to the first string or the first wire that runs from top to bottom. What I'm trying to say is that all these walls that are near the positive are connected from top to bottom. Okay, so that is the same concept with this negative part. All these walls that are near the positive are connected from top to bottom. Okay, so I saw that some of your breadboards that are being made these days, they may have at the middle right there, at the middle of this, you may see that these two wires may be disconnected right there if you open the back part of this breadboard. So you need to check the continuity using a meter to check if the wires are connected through and through. But that is basically it. The wires should be connected from top to bottom. So we have two wires. The first one, which is we call the positive, connects all the dots or all the holes that are near the positive. The second one, which is negative, connects all the dots that are near the negative. Okay, so that is the same mechanism. Okay, let me try to put this back in. Okay, perfect. So that is the same mechanism that was implemented on this side of the breadboard. Okay, so let's get back to the central part of the breadboard. Okay, so for the central part of the breadboard, I would like you to hold your breadboard like this. Okay, so each and every part, we have small wires that connect these walls. So I'm trying to say that from this wall to that wall, there is one wire connecting these walls. So we say we have one continuous line. Okay, so from the next one, the next from the next wall to the next wall down there, the lines are connected. So the lines, these walls are connected in this way. All right, what do we call this? I don't know if in a vertical manner. Okay, these lines are connected in a vertical manner. All right, so these walls are connected vertically from this to this. Okay, so this part separates this part with this part, so there's no connection between this part of the breadboard and this part of the breadboard, but there's a connection between all the vertical holes are connected right there. All the vertical holes are connected. If you hold it like this, all the vertical holes are connected. The same applies for this part of the breadboard. All the vertical holes are connected. I'm going to test this, or I'm going to show you what I mean by using continuity on a meter. So let's get there. So guys, I'm going to show you, or I'm going to prove what I was saying right there. Okay, so the first thing that we want to do right now is to test for continuity of these walls. Okay, so we are going to start with this first red line right there to see if it's continuous all the way through. So we are going to plug in our blue wire there on the first positive from the left, and then plug in our white wire on the last positive from there, right? So if you look, let's test our meter to see if the continuity works. Okay, it works. So we need to, if it's continuous, we should hear a beep sound. We should hear that sound. Okay, so this means that this whole line is connected. No matter which wall you plug it in, that whole line is what? Is connected. Okay, so with that being said, with that being proved, let's move on to the negative wire. So remember guys, as I already have told you, some breadboard that are being made these days, at the middle of this breadboard, you may see that the wires are not connected, that the left part side relative to this part, you may see that the left part of the breadboard of this line is not connected to the right part of the breadboard of this line. I've charged a lot of people who came to me with this problem. They don't know that the problem is with their breadboard. They be thinking that their circuit is not working. So you don't want to come to me and be charged. So always check that your breadboard is continuous in this way. If it's not, you can always put some jumper wires there. So let's test this negative wire. Let's test the negative line, the blue negative line. Okay, perfect. So the blue negative line is continuous. Let's go to the other rail, this rail, the outer rail. Let's start with the positive. So let's test this. Perfect, it's continuous. So let's test this, the negative blue one. Continuous again. So let's test this part. I'm not going to test each and every wall, but I will just demonstrate so that you understand what I was trying to explain to you. Okay, so let's test this first line right here. Okay, so let's put our wire there, then put our wire. It's supposed to be connected. The first rail is supposed to be connected. This first rail is supposed to be. So it's supposed to produce a beep sound. Okay, so let's choose another random line in this. Okay, so same line. Perfect. So if you connect lines that are not connected, the beep sound should not be heard like this. Okay, if you connect any other lines that are not connected, this beep sound should not be heard. So that is it. So always remember that these lines, or these lines that run from here to here, are always connected. This is connected, this is connected, this is connected as we go. And the same thing applies for this. And for these large ones, the positive ones, the positive rail is all connected, the negative rail is all connected. Okay, so you may be wondering, is this positive rail connected to this positive rail? Let's check it out so that you can see.
So as you can see, the positive rails are not connected. Okay, as it's the same thing with the negative rail. You can check that yourself. So that is all about what about our breadboard. So what we want to do, guys, is for you to take your 220 ohm resistor, 220 ohms, your 220 ohm resistor. Now check your LED, check, make sure that you have your microcontroller or the Arduino, check, make sure that you have the cable, check. Okay, so, and make sure that you have the what, the breadboard. So we are going to wire this circuit on this breadboard. So before we do that, we want to start where we left. Last time I taught you guys how to blink the internal LED or on the microcontroller on pin 13 right there. So it is where we are going to start. Okay. So we are going to blink, we are going to use pin 13 to blink this LED. Okay. We are going to use that same pin 13 to blink this LED. So don't worry, guys. Our first step, that we don't have to code anything in our first step. What we just have to do is to do the wiring. That is all. Okay. So to do the wiring right there, we want to use pin 13. Okay, and use the code that we had that we used the last time. So what we need to do, guys, is for you to get your jumper wires. Okay, and you to get what, your Arduino microcontroller. Okay, so you want to locate your pin 13 right there. Okay, so I will be using blue as positive, then this is negative, and you also want to locate your negative or your ground. So we have a couple of grounds. We have two grounds on this analog side, and then we have one ground on this digital side next to pin 13. So I will choose to use this ground, but all these grounds are connected. If you change your continuity, you will see that it's continuous, all these grounds. So what we need to do, since we agreed that these lines, this vertical line, these lines are not connected. If we count lines going in this direction, they are not connected, but going up and down, they are connected. So we need to put our LED right there. And mind you, guys, the longer side of this LED is the positive, the shorter side is the negative. So when you plug your LED on the breadboard, okay, we need to wire it exactly as what is in there. Okay, so you may be wondering which pin will be our pin 13 according to this diagram. So your positive part, this positive part will be your pin 13, because it is the one that will be producing energy to this LED. Okay, so your pin 13, which is this is connected to the resistor. So we are going to put our pin 13 right there, and then we are going to take our 220 ohm resistor and then connect our pin 13 to the resistor, and then take the other leg of the resistor and then connect it to the positive side or the longer side of the the LED. Okay, so right now we are right there. After this, we are now right there. Well, this is the leg of the long leg or the positive leg of the LED, which is this one. Okay, so we have the LED, which is this one. Then we have the ground, which is this, or the ground. Okay, so this is the ground. So you need to take this and put it right and connect it to the ground. Okay, then after that, guys, always remember that when you run your code, it gets stored in the Arduino. Your latest code that you have uploaded in your Arduino will be stored for as long as the Arduino exists. So whenever you plug in your cable or you plug in your source of energy, that code runs. So we want to use the code that we used the last time to blink this LED. Okay, so we don't need to change anything on our code. So remember, the last thing that was on my code the last time was a blink code. Okay, so I'm just going to plug this in. So if you remember the last time on my video, I had put 5 seconds for turning on and then 1 second for turning off. 5 seconds on, 1 second off, 1 second off. Okay, so if you check the frequency of turning on and off of this LED is the same as the frequency that this LED is turning on and off. Okay, so we may want to play around with these numbers. Let's put 500 seconds turn on, 500 seconds turn off. Let's do that. Right, I'll just change. You don't need to see this, guys, since we already did it. I just want to prove to you that this LED is what is using the code that we coded last time. Okay. So we want it to turn on for half a second and then turn off for half a second. Okay. Okay. Okay, so all right, so I've uploaded the code for it. Okay, pin 13, pin 13, pin 13. Okay, the code is successfully uploaded. As you can see, the frequency of this LED has changed as well as the frequency of this LED, but these two LEDs are in sync. Okay, so I'm going to teach you how to use another pin to turn the LED on and off. Okay, so what you want to do, guys, is to set your pin in the void setup. Pin mode, instead of 13, we have put 10 right there. And then in the void loop, digital right high, we are going to put pin 10 there. So in this second command, digital right low, we want to replace pin 13 with pin 10, as I have done right there. Then we are going to make sure that our COM port or our board selected is Arduino Uno, which is COM port off, like that. And then we would like to upload. So we've uploaded successfully. So as you can see, our pin 10 is working just fine. If you look closely, it's really pin 10. We'll lift it up so that you can see that it's pin number 10. Okay, it's inside the board. The blue one is connected to pin number 10. I don't know if it's clear, but yeah, that's pin number 10. So thank you very much for watching this. Have a good day. So in our next video, you are going to learn about variables. Why are variables useful? So stay tuned, guys. Click on the bell icon so that each and every time that I upload a video, you get a chance to see it. You get a chance to have fun with your electrical components for now. Remember, the journey is long. After this Arduino series, you are going to have the PLC series, where you guys learn the real programming. So right now we are just warming you up. So it's important to follow this through. Thank you very much.